Hi, my name is Dave Coltrap with Division 7 Systems. We're the representatives for Hunter Panels here in Arizona. And today, we're here at Construct 2012 in Phoenix, Arizona, where we have 3 experts from Hunter Panels' XCI division. They're going to answer some commonly asked questions as it pertains to exterior wall insulation products. So check it out and tell me what you think. We have McGregor Pierce with Hunter Panels' XCI division, who heads up the product division. What is CI? Tell us about CI.
Continuous insulation is described as any sort of insulation, but foam being the primary one, that crosses structural members that breaks up the idea of a cavity insulation. So it's a form of adding insulation to stop thermal bridging, whether it's from the exterior in or interior out. So that's a basic description of continuous insulation.
Gotcha. There's a lot of talk about IECC and ASHRAE 90.1. How does that play into CI?
All right. Both those are standards that are set by different groups. The ICC has the IECC, and then ASHRAE 90.1 happens to be a standard. ASHRAE sets the standards for insulation on all buildings, and the standards that they set are minimals. It's just the bare minimal, and from those codes is what states adapt as their energy code.
Gotcha.
So, and the reason there are 2 conflicting ones, and some states are prone to go with ASHRAE 90.1, which a lot of states today have adapted the 2007 version of ASHRAE 90.1, and then there's some states that have that use the IECC to set what their codes are.
And what does IECC stand for?
It's the International Energy Code Council, and so which is eventually all part of the ICC.
Gotcha.
So, and they're setting codes, and IECC 2012 is their latest version, and Maryland was the first state to adapt that as the basis of their energy code. North Carolina has jumped on that one, and there's 3 or 4 other states, I believe, at the moment that are also considering the IECC.
Gotcha. You know, there's a lot of talk about code compliance, things of that nature. Mm-hmm. How does the NFPA 285 play into all that with the code? Okay,
that's a great question. In the International Building Code, the IBC, there is a whole section, Chapter 26, that deals with plastics, and in particular foam plastics. And in there, there is a definitive paragraph that states that the entire wall assembly, and this is on building types 1, 2, 3, and 4. Building type 5 is exempt from it because it's smaller buildings and wood's allowed in it. But it's very clear that states that the entire assembly shall pass the NFPA 285. All right, so what does that mean? It means that the NFPA 285 is a full-scale test of 14-foot wide, 18-foot tall, entire wall assembly, interior drywall to the exterior cladding, all the pieces. And it's required when foam plastics are used, thus being in Chapter 26. So the use of our product, polyiso, dictates that assembly needs to pass that.
Gotcha.
So in this test, there is a window opening. It's attached on a 2-story concrete apparatus, and it simulates a fire in the first level. The fire starts inside the room. Eventually they have some fire gas jets that are outside right above at the window head, and it's a 30-minute test, and it simulates the window being blown out and the fire not getting to the next floor. So in 30 minutes you can't have any flame going in. There's a whole set of criteria that are determined by thermocouples that are put in both outside the cladding, in between the cladding and the insulation, and inside the insulation.
Gotcha.
And each one is monitored for all 30 minutes.
Gotcha. That's good information.
Yep.
Thanks, McGregor. Really appreciate it.
All right. Thank you.